Hello, everyone, and welcome to the April 2021 Integration Down Under. We're a little bit later this month, but we just didn't get ourselves organized as well at the start of the month because of Easter and things. So I'll just go through a couple of slides quickly, and then we'll get straight to Mick and his talk. Oh, too far. Okay, back one. There we go. So we've got our organizers, Martin, Dan, Renee, Wagner, and myself. And this is a new one this month. We're actually using a product called StreamYard to stream to the YouTube Live. But I will also put a recording up once we're done, the same as we normally do. But this is a little bit better tool to use to add everybody to the stream. As you can see, everyone along the side over there, you can wave at everybody. And also in StreamYard, we've got access to the questions in the YouTube Live. So if you want to post a question in there, we can get to those. So tonight we have Mick, integration best practices, starting with Dapper. And so basically, I will turn it over to Mick. Let me just get rid of my screen. Add Mick's screen, and then I'm going to get rid of my key.
And I think, Bill, you got rid of you. All righty. So I think we're underway. So thanks very much for having us, folks. And I'm Mick Badran. And I wanted to share with you tonight or today, wherever you may be, just a great piece of technology that I've been keeping an eye on for some time. And this is called Distributed Application Runtime, or Dapper, as you'll get to know. And it's not often that, a smart piece of technology comes along that really makes our life easy, and as integrators, as application developers, and so forth. And I just wanted to be able to share this with you tonight, and just show you some of the things that I've learned and what I use it for. So our session is basically an introduction to Dapper, and it has been around for a while, and it's evolving and basically got broader reach. So where this sort of comes into it is that, if you think about developing solutions today and developing applications today, right from the word go, you've got to kind of think about, well, how do I factor in just getting up off the ground? But then next week, I'm going to be asked to cater for millions of rows and millions of records and millions of transactions and so on. So, how do I handle that scale without a significant application redesign? So these are some of the things that we need to think about, going forward as part of our application building and as part of our architecture and solutions that we want to design. How do we do that in the most cost-effective way? So something that I quite love is, back when we sort of, started to have a look at the cloud, then there's a famous quote from Bill Gates: 640K ought to be enough for anybody, back in 1981. So, how much has times moved on from there? So in terms of just quickly, who I am, basically CTO, director of Solvit IT today, and MVP, insider advisor, and been in this space for a long time. And I absolutely love the technology challenge, new technologies coming along. In terms of, just who I am and my family and so forth, when I'm a superhero on the weekends, this is honourable child number one and the infamous grandma, and together they get up to no good. And this is my daughter who, butter wouldn't melt in her mouth. And realistically, this is my dog, Honey, who is the only person that listens to me at home. So it's a good bunch. So in terms of, getting onto our application development, it's like, well, where do I start? There's so many frameworks, there's so many places I can end up, what cloud, which cloud, what service, and that choice of technologies is just bigger and bigger and bigger. Invariably, what I see a lot of people do in my, consulting world is just basically go back to what they know. So you end up having monolithic applications that are pegged together, that are very difficult to have multi-region, resilience, redundancy, fault tolerance, backup, spend millions of dollars trying to achieve those things. It's not as hard as what you think it is. So to break it down even further in a concise form, essentially the business sits on the left-hand side and says, well, here's all the features I want you to build. And over on the right-hand side, us as the implementers, programmers, designers, architects, whoever, we need to make sure that works. And particularly when we start to look at, you might have come across these terms of modern development. I love that one. So, I'm developing a solution, an application, whether it's, mobile first, whether it's some sort of, Angular, web-based, mobile, cross-platform. Maybe it's not even there. Maybe it's in the back end. Maybe it's, API economy and using API management, and how can we best leverage what we already do to the world of APIs. And we sort of explore down, B2B and B2C and partners and marketplaces. And, so there's a whole raft of different places that we can take what we build. And what I'm just trying to get across to you guys is that it's not just, clean cut 3-tier architecture. Here's your app, here's your APIs, and here's kind of your data store, your data layer, because these days there's so much more to it. And they're kind of in the set of features. Now we then look at, well, how do we handle scale? So, every developer kind of looks at it and says, well, it works okay on my machine. I don't know what your problem is. I've got, 5 entries and everything works fantastically on a developer machine, regardless of, how you code it. You could use SQLite, for example, just running some proof of concept. And it's not until you get 2 users, 3 users, 10 users, concurrency, memory constraints and memory pressure and thread pressure and, just things that you're going to get in your day-to-day. How do you handle that? How do you go from kind of, the one n case to the n squared case? And, some of the other things, well, what about availability? How, do we care? How are we going to ensure that our application is up? Or how are we going to ensure that it's portable? Because, what I see a lot of clients doing today is that, we're running it in this cloud today, but tomorrow we want to run it in a different cloud. Or, a job I'm working on at the moment is porting a data warehouse from one cloud to another. So, how do we ensure that happens? And things like data integrity and, to the business, all these things should just happen. Then we throw in on top of that things like, managed services. How can we build faster? How can we deliver and get out to market faster? And, ultimately that's where we create our business value. So in terms of the agenda tonight, why do we want to use such a technology such as Dapper is kind of the question. And then, well, what is it? And I'd like to show you a couple of demos and so on. And then we can wrap up and sort of have some Q&A. So I do want to leave some time for Q&A. And I really appreciate you guys making the time to be here and listen in. Listen, look, be interactive. It's your session as much as it is mine. So why should I even worry about this piece of technology called Dapper? And what the goal of Dapper is to provide you a portable, run anywhere technology that absolutely allows you to focus in on what you want to build rather than trying to have these challenges that we have when we, put in place a distributed application. So state management, storage, How can I be notified by particular events and things like that? So, if I take events, for example, PubSub models, or event-driven architecture, which you might have come across, and we love, eat, breathe, sleep this stuff, and if we can get a solution in that context, oh, it's heaven, right? It gives it so much more longevity. Now, you might, and I absolutely 100% believe that in Azure, as developers, we are so spoiled. We are so spoiled with the level of technology and what's at our fingertips that, it's unmatched, unparalleled. And the way that you work and how you work is just phenomenal. And then you sort of go to these other clouds and you're kind of going, well, hold on, it doesn't quite work the same way. And I've got to kind of do a roundabout way. And, my methods have to finish within a certain time frame, as opposed to the 10 minutes or the 15 minutes that's advertised on the box. So, maybe I've got a particular way of doing a PubSub model or an event-driven model in Azure, for example, using Event Grid and being able to leverage those off elsewhere. But then when I move over to AWS, I've got to redesign that part. I've got to redesign my plumbing or my scaffolding to give me that, to give me a comparable level of service of being able to raise an event and sort of react and respond to those events. So I might use the send service and I might use Lambda functions, and, it's not the same. I've got to plug in, I've got to swap in and out my modules to be able to do that. And so, moving from one cloud to another cloud or making that portability isn't as easy as what we'd like it to be. So Dapper provides, if you like, a facade, and if you like, a way that our application space interacts with, whatever is in the back end. And this is where it abstracts that back end away from us so that it is designed to run anywhere. And we just talk down to the Dapper APIs, and maybe that's a NuGet package that we drop into our whatever, application we're building, and it looks after the specifics. So we don't really need to know too much about that back end. But the more that we know, the more we can drill in, and the finer tuning we can do a lot of these things. And so the key is that we kind of have a standard way of working, which is what Dapper exposes, and it's very extensible, rather than, versus knowing that we're dealing, we're running a Redis cache down below, and, here's how we talk and interact to a Redis cache. So these are just, some of the things, and other bits and pieces around, well, the classic kind of storing secrets, accessing some saved state. And that's always the question, today. Like, take, for example, you're deploying locally, you're deploying an application on premises somewhere, let's say, or you're deploying the same application to Azure, or you're deploying the same application to AWS. If we're storing secrets, chances are you're dealing with that particular piece in 3 different ways, depending on where you're storing them. So if you're storing them in Azure, for example, most likely you're using Key Vault. If you're storing it in AWS, most likely you're using a parameter store. And then if you're storing it in sort of, an on-premises solution, you're doing it a different way. So I call that reinventing the wheel. Why should we as developers be spending our time, reading and writing so that we can get configuration parameters and things like that into our applications and from these secure stores? Why not drop, Dapper in, for example, and just go, give me my configuration. I'm in dev, I'm in UAT, I'm in prod, please supply me my parameters. And it goes off and does the work. And, so these are just some of the things that we might want to look at. And obviously we speed up development. So in terms of the services that that Dapper has, and these are the, some of the components that it has. So through, through configuration, through API calls, and through components, we can do things like, service to service. So we could say, go and call another service, and here's a way of doing it. Now, we don't actually care where those services are from our application, but we need it to go off and run. So, for example, we could pass a call into Dapper that says, go to Twilio and send an email, and it looks like this. Or, we want to do some state management. We want to be able to say, hey, here's our class, here's some parameters, or here's a serialized version of our class, go and save it. Don't care where you save it, just save it. And then when I want to recall it, I want to be able to recall it. And the beauty about, for example, state management is that if the Dapper infrastructure is being shared across your applications and things, they can share that state management as well. So just exactly the same as PubSub type component in there as well, so that I could publish something in one area of the solution. Maybe it's an order that's gone through, and we then get the subscribers. We subscribe to that in the back end somewhere else. But the common thread here is that you're talking to the same resilient Dapper infrastructure that has been footed up. And there's various other things in here as well. So the goal of Dapper really is that, it's open source. So it's not owned or you're not being sort of driven down the garden path by one particular vendor. It's open source, it's portable, it's event driven. I mean, that in itself is just awesome, right? Like, you want to get on board with these sorts of technologies as much as you can, because yes, we can do, real-time request response, millisecond type stuff. But for all the other stuff, event-driven, then, as you're aware that, hey, an event comes into the infrastructure and says, this just occurred, an order was placed. And then today we might have 1 or 2 subscribers. Tomorrow we might have 10, 20, 30 subscribers. But we don't actually need to recompile or change our code. Our new bits and our new modules can just come on board and basically subscribe to those events, as I'm sure you're more than familiar with. But the part that I do want to sort of show is, or talk about, is the Actor framework over here, which that's something that has been quite of an interest to me for some time, and that is being able to have this Actor type paradigm where you can define a unit of work, which is an actor, and the rest of what you want to do. So where that state is, what that actor operates on, the data that they change, being able to, when that data is stored, concurrency, threading, all of that is handled by the runtime. And just as a side piece, things like when you're playing games on Xbox and various other things, they use this sort of Actor framework through Service Fabric and through the Azure runtime quite frequently and quite heavily, so that the proof is in the pudding. They do eat their own dog food, so that characters in RPC games and things like this are all very, very much actors, and they can interact with the world on their own terms and read and write their own data and things like that. So it becomes quite a fascinating area. And bringing it back down to home really a little bit more is, an actor might be, for example, something that governs a shopping trolley as it's going through a checkout process. So each individual customers with their active shopping trolley basically might be an actor or two. Quite fascinating. So how do we run this thing, and how do we sort of we sort of use it? So we've got a few different ways that we can do it. One is that it can be self-hosted, which I've got here at the moment running on my local machine, and that just means that You can go and install it. You've got a command line that you install, and then you just run an init command. And the init command will then go and provision what you need it to provision based on your configuration. And then obviously it can run as containers in Kubernetes or Docker or, however and wherever you'd like it to do. Now, there's a little bit in there that you might see, which is gRPC. And that's another piece of technology that gets me really excited. It is so much faster than the traditional HTTP, even HTTP 2.0. It uses protobuf over the wire and adds some serious throughput and serious low latency type calls. So, if you can control your service to service invocation or APIs to other APIs, so you might have heard of things like back-end APIs and then front-end, back-end APIs for front-end, which is like more experienced APIs. So if you've got API layers that are sort of serving out this greater solution, absolutely, you should be using gRPC across those. Now, it's good to see that Dapper comes just out of the box with that and says, hey, how do you want to talk to me? HTTP, HTTPS, obviously, and gRPC and the rest of it. So really, really fascinating. Now, in terms of these building blocks for things like the cloud and edge that they have, this is more of an exploded view of just what we spoke about a little while ago. But all very extensible. So bindings and triggers, for example, how do we extend out this Dapper environment through bindings and triggers? And we create our own bindings or triggers and sort of deploy them into the runtime. Now, as far as on the flip side of, being a client, how do I use this stuff? And typically, if you think that Dapper exposes a set of APIs, then we can call these APIs through, whatever tool, whatever language, whatever technology of choice you'd like them to be. So Microsoft have been quite busy in this space. So things like Logic Apps, things like Azure Functions. Azure Functions have an extension that will talk Dapper, allow you to read and write state and publish events and things like this through bindings of a function. So just to let you know, there are ways that we can integrate into this technology through many different ways. So it's not just I need to use this. I need to go back to my favorite language of choice and write a couple of thousand lines of code to make this thing do absolutely anything. I'll just sort of mention here as well, folks, that this this observability. You've all probably seen App Insights, and that's my nirvana, right? When we're looking at what in the world's going on, App Insights for me is like, oh wow, if I could get all my solutions to App Insights, it'd be absolutely amazing. And the reality is I get maybe about 60%, just depending on the circumstance and situation. So observability is to say that through this we've got the ability to audit, log, monitor, see, what the calls are doing, how they're doing it, irrespective of having sort of App Insights and things like that. So if you think about it running, portability and moving this from on-premises to cloud or cloud to or sharing across regions or even, having hybrid cloud solutions, then, it's very handy to have this functionality built into this technology rather than having to, once again, implement it ourselves. And I just wanted to mention a little bit about the Actor itself, which is, if you're not familiar with the Actor, but just think of it as the smallest piece of work, which in our world typically equates to a class or equates to a class which has a series of methods over it. Maybe it's an order, maybe it's a game, maybe it's a person or a user info or something. And those methods operate over that class and with data and things like that. So what an actor does is essentially the underlying framework, the Dapper runtime and so on, will prepare that class for us to go and call it. So things like storing information, talking to other services, doing a lot of this other stuff, that's kind of passed in and provided to us by the runtime, by the Dapper runtime. So we don't have to worry about all of that. We can just ask the runtime, hey, can you do this for me? Can you load up my previous state? Or can you, can you update my state? Can you update some data? I want to store this. And, maybe it's a day in between when sort of method 1 and method 2 were being executed on the class, or maybe it's a week or a month or seconds. But we don't need to worry about that because that resilience and persistence and fault tolerance is also there in the runtime. So you'll see when we talk about Dapper, it's you'll read and you'll hear a lot about it being called a sidecar architecture. And what that means is it's something that you can bolt onto your existing application, not to be confused with things like side loading, right? Which you might have read elsewhere on, phones and various development that you might do. You might side load modules or applications into an environment. So a sidecar is, in the case of Dapper, it's a process that's running or a set of containers that's running, and we communicate to those through a set of APIs. And they're listening on a particular port, and we can communicate, if we make REST calls or API calls. Now, fortunately for us, we don't need to necessarily get down and dirty into that level. We can drop a NuGet package or some sort of SDK into our language of choice, which then under the covers handles all those calls for us, and we can deal with higher level entities. So it's quite handy, quite nice. And obviously it's very extensible. So what that looks like in sort of a more exploded view is that, I might have some code running as code A, and I've got code B, which could be a service. It could be, anything at all, really. It could be, a website. It could be, a mobile app. It could be, something that's run in the background, in the back end. And it knows about Dapper, and essentially the Dapper sidecar basically is there as, is footed up as a process. And we can have multiple instances of Dapper for whatever reasons and underneath that. So if you think about, that's kind of the runtime that's answering these calls and communicating over the APIs. Now, behind that, we might have common services such as using the same Redis cache, for example, or using the same Cosmos DB that we configure in the Dapper environment and runtime, so that even though we might be talking to our own instance of Dapper, somewhere or other, there's some cross-pollination and sharing of these services. So let's have a look at, in terms of, what I want to show you, let's have a look at some of the code now and for it to go off and run. So I'm going to just, hopefully you can see that. Let me just get to the bottom of this window. There we go. Beautiful. Okay. So I've gone in and previously installed, if you go to dapper.io, it's a great place to start, and it'll say, hey, you want to get started? Click here to install the Dapper CLI. And so we go off and do that. And at the beginning, here's, I'm running a local instance of Dapper. And so as it sort of starts up, I can list, I can, interact and play around with this. I can also, talk and connect various Dapper instances together as well. So it's truly, sort of location agnostic. Now once again, I'm running this on my local machine. So I'm just going to stop any back-end services and the like. And we can see that once I do an init, it'll go and basically install a local Redis cache. It'll install a couple of other things for me as well and have those listening. And it uses something called fast HTTP as a web server to provide the socket endpoint listening. So just to give you a little idea, and if you do want to jump into here, because it is open source, and if you do want to actually change this stuff, then, think about extending your code around fast HTTP. So the first thing I'm going to do is essentially come over here and run. Now, what I'm doing is running this instance of Dapper, and if I just did a run, what it would do is just go off and pick a bunch of ports. So remember that we're listening. That Dapper is an API, and it publishes. I need to talk into Dapper through the API. So what it does is just randomly pick ports. And so what I've told it here to do, and this is just based on some code that I've already got. So I wouldn't normally kind of pick these arbitrary sort of random numbers, but this port here, 61230, is the port that the gRPC connections that it's going to be listening on. The application port is my application that I wanted to run for a particular example. And the H port over here is the HTTP port that that the Dapper instance would be listening on. So the part really here in question that you might be, that's sort of worth noting is that port there is a way that, if you think about, for example, Dapper has a variety of different architectures under the cover. So we take a PubSub model, and Dapper needs to know about the subscribers to topics and to certain events that it's going to receive coming in. So anybody can publish, right? So all these people can publish and say, hey, here's an order placed event, and here's the data to do with that order placed event. What the next piece of the puzzle is that the Dapper runtime needs to actually go back and call the subscribers, or needs to invoke the subscribers. So it needs to know who the subscribers are and how to communicate with them. And that's where this particular piece comes into play, where we're sort of saying, here is the subscriber. So I've got a web application, a web API listening that's a subscriber on that particular port. And that's what we're doing here. We're telling the Dapper runtime, hey, listen, if you want to talk to a couple of subscribers, you can find them here. So absolutely, the Dapper runtime needs to go back and talk to your applications, depending on what you're doing. For simple things like state management and the like, it doesn't need to do so. So this thing's just starting up, as you can see, and we're away. It's got a fair few bits and pieces in there that we can look into, and it's off and running. So I'm just going to move this guy over to here. Hopefully, yep, that looks good. So I've got some projects over here that, and I'll just take the hello world to start off with. Yeah. Okay, so I'll take this hello world, and this is probably about as simple as, I wanted to show you. Oh, let me just show you a couple of cheeky things as well that has just arisen. And so when we install Dapper, underneath my user profile or wherever, whatever that interactive user is, there's a folder called .dapper. And under that .dapper, there's a bunch of different configurations and components that are in YAML files that we may be interested in tweaking. So, for example, things like, the configuration, where you might actually find some endpoint addresses, and also if we look at some of these components. So if I want to look at, for example, my state store, well, what is the state store that is backing my Dapper implementation at the moment? And I've got a Redis implementation or a Redis instance, and that's in a container. I've got Docker running on my machine, and the way that we get to Redis is through that. Now, if I wanted to have something else, Cosmos DB, I would change the configuration in here and talk to Cosmos DB. So as you're probably guessing, the application itself doesn't need to know anything about it. And then if I look at my PubSub, for example, my PubSub is also implemented through Redis. I could use things like Azure Service Message Bus if I wanted to. So in my hello world, so I've got really just only one routine and a couple of things. So the first thing that I would do, and I'm using C#.NET. So the first thing I would do is come and create, add a reference to Dapper client. So this client allows me to talk to the Dapper service and just do some fundamental things like storing state, retrieving state, doing a few other things. But if I then wanted to start to receive events, subscribe to things, then I need to approach this a different way. But for, just out of the box, very simple stuff, then I can, I can just drop this client in. So let's just see what the code looks like to start off with. And so once again, I could do this in Visual Studio Code. I could do this in many different languages. This was just easy to come to terms with. Now, the first thing that you'll notice up the top here is that I'm using a gRPC store. Now, this 61230, just to give you an idea, was this guy here. So when I said start up our infrastructure, I needed just to have a few ports, well-known ports, or just ports that were defined. Otherwise, I'd have to provide some discovery type service somewhere that sort of interrogated the Dapper instance to find out, just where all these ports were. Or for the demo of this integration down under, I could just hard code the port for tonight. So, I'll take that one just for now. So let's run this. And I just want to kind of show you what this thing looks like. And let's jump over to here. So I've got, welcome to this Dapper demo. So for the first one, we're just going to do a hello world state management. Literally the most, and there's a breakpoint that we're dropping through. I'll explain the code in just a moment. Literally the most part of this work was the console write lines. And so we've got a few bits and pieces like, saving an object. If I had other applications running, they could all be sharing the same instance, and, don't get me wrong. So let's just walk through some of this code. And so the code for sort of step one and the code for step two. It's a it's a console. It's I just wanted it to be as simple as possible for us. And I just wanted to take advantage of some async stuff as well. So the simple state storage, I've got this routine here that says go off and init me a client. Give me a client to my Dapper instance. So what that init client looks like is this bit. I've got a client builder, and then I've got this use gRPC endpoint. And really, we could have a variety of different things in here. There's some sort of security that we've got in place. We've also got HTTP, and I've got a variety of different options in here as well. But this is just a high-level client that under the covers creates your API calls the Dapper API, and then comes back. So if I'm ever stuck, or if the client doesn't do what I need it to do, then I can always go and, invoke these various methods, which basically, go off and call a particular API request that the client implementation hasn't really covered at that point in time. This piece of code here, really, I just want to get a client. That's it. Now, this, if you're wondering, this stuff can actually come from a configuration as well. So I can use my app settings.json or my application configuration and stick all my Dapper configuration stuff in there, as opposed to hard coding it in my application, which, for the purpose of tonight, I just wanted to keep everything in front of you so that you could see it from start to finish. Now, once we've got our client, no calls have been made at that point in time. What I then do is to go off and say, go and get me something from our store. I've called this piece of information times run, and what we're going to get back is possibly an integer. Now, if you have a look at what the store name is, the store name here is called state store. Where did I get state store from? I got state store from just my default implementation, and the name here is state store. So when we did a Dapper init on the command line, it went away and said, hey, I'll go and provision all this stuff for you. Depending on how much of the configuration I wanted to control, I could change that. But I just thought I'll leave it run with defaults and we'll go from there. So that's where state store comes from. So when you sort of run your code and you go, I'm just going to use any store name, you can't, just let you know. So you do need to sort of, work that out with your Dapper implementation first, or your Dapper sidecar, and then kind of, come back. And obviously there's a whole bunch of APIs and things that expose that you can create all this stuff through, but through the Dapper client, through this particular NuGet.NET package, we can't. So in this case, we just go off and get it, and then we come back and effectively save it. I just do a couple of things like look at the value, add one to it, and then save it again. And basically we save an individual value. In terms of my application code, I don't really care where it is. I don't care, how it's being saved. Whether it's being saved in Cosmos DB or Redis or whatever, I don't need to know about the Redis client. If you've ever sort of used Redis, there's kind of particulars about the client. Some clients have greater level of functionality than others. Here we're just retrieving, just storing, retrieving, whatever. Now the second part to this is that I'd like to actually use a more complex object as opposed to just a simple integer and so on. So in this case, I've created an object which is a user object, and the user object just looks a little bit like this. This is local to this project. It's a class. It's got full name, email, and a receive date time field. And here on line 59, I'm just basically coming in and retrieving that value, just similar to what I did at the top there. So what I wanted to do was just go and say, hey, do we have it in our store? And as you're probably thinking, many different clients, many different instances, client instances can be running, talking to the same Dapper infrastructure. So one client, for example, can be updating, storing this stuff. Another client can be reading it, or they both can be, or they all can be interacting in the same store and kind of, waiting for certain data to be available. So it's not necessarily just locked away to one and only one instance if you don't want to. And so, here I just come along and say, just save the object and give it a name, give it a key name so we can bring it out, and just, use that whole object itself. I do a console write line and basically serialize that out to JSON so I can print it out on the screen for us. But just to give you an idea that we can use complex objects, provided they can be serialized into JSON, and we control how that JSON and what that looks like. And because I'm talking to the Dapper service over gRPC, then this stuff is sent over binary and it's compressed, and it's very fast in what it does. Now the next little piece in this demo is this transactional async. So there you saw just interacting with the state service, and essentially storing one bit of information and retrieving one bit of information. Here we've got the ability to exactly the same sort of code. I've got go get me a client. I prepare a data structure here, if you like, and I sort of say that I'd like to have a transactional request, a list of these transactions. So in other words, rather than just do one at a time and make one call and come back again, what we're doing here is loading this up so I can have as many as I want, and essentially, then just execute it in a batch, such as this. It just says, against this store name, here's a list of operations that I want you to do. Go and do it. And so in this case, you'll love to see the word upsert there. So here's the key. Here's the data itself. And, this is the operation that I'd like you to do on it. And then to retrieve that information out of there in the same sort of fashion, I can give it a list of keys like Monday, Tuesday, Wednesday, Thursday, Friday, etc. And then I can come over here and say, go and retrieve it from that state store, if you like. This little 0 at the end that I've added is the degree of parallelism. So maybe I want to sort of be mindful of the number of threads that I'm using. In this case, 0 just means open the floodgates, baby, and go for it. And really, this just comes along and just outputs what we've retrieved. And it's all, all very quick and very fast. So the key here is that the application itself didn't really need to know too much about Dapper, the implementation of Dapper and where it was. And so, I've just gone off and executed that now, and you can see that this is sort of outputting from that transactional fetch and things. So the code itself is not too extensive. Okay. Now this is sort of a starting point for us. Now the next little part I wanted to just show you, I've got this in the one application. It doesn't need to be, but I've got this PubSub kind of model, and the way that this happens is for this particular solution, it's a web API, and I've got the Dapper ASP.NET Core here. So in other words, at the back end of my web APIs, this web API is going to be Dapper aware. So I could have dropped in the client and done that client stuff and things like that as well, as you just saw. But there's also a nicer way and a tighter way to integrate into my web APIs. And by doing it this way, I'm actually able to have things like a PubSub model and things like that in here. So where are we? That's that guy. Okay. So if I go into my startup, the part that I do want to just show you is that by making that reference, we've got this thing called use cloud events and map handler. So what that means is that allows communication to Dapper, and it also provides certain scaffolding that Dapper needs in this project to be able to communicate to it from the other way. So if you think about it sort of doing a PubSub type model, then there's got to be something exposed out of this solution for Dapper to communicate to say, hey, I've got an event here that you need, that you're interested in. Let me pass it to you. And that's kind of what this does behind the scenes, under the covers for us. This use cloud events allows the extraction of the event data that comes through in a nice way, and basically looks after and unifies a lot of that for us. So that's all we need to do in the startup world. Now on the controller, we've got a couple of things on that we do. So, or wherever it may be, right? This could be code anywhere, and I'm just sort of putting it on a controller for you. So this here basically publishes an event. And in that previous example, in that console hello world where we're playing around with state, from that client, we could also publish events. And what this does is effectively use an HTTP client. We could do this a bunch of different ways, but here's our route. So we can go and publish an event, and we call the Dapper API, if you like, directly. So this here is a known kind of, this is a known address. This here is our HTTP endpoint that our Dapper infrastructure is listening on. This here is our topic, and this here is the actual event type or name, if you like, that we're actually sending to. Now, down below here, I've actually got the subscriber part of that as well, which is to say that, and you'll notice that this is the same name as what is, wherever you are, what is up there. And that's because this is eventually telling Dapper, hey, listen, I'm this routine, and I listen to this topic and this particular event. Now, there's an event or piece of data that comes around called game stats, which I've actually created in this solution, which just has a few bits and pieces on it. It's really just a class to serialize and not serialize. As a side note, just to let you know, let's say you don't actually know what the shape of the JSON is that you're getting over the wire. So, yes, this from body is always awesome in, web API projects and things. And here I've got my game stats because it's kind of a certain shape of JSON. But let's say we're making a little bit more of a broader or generic type interface here. Then instead of using from body, I can use JSON element, and it serves as the same, where it'll take whatever the JSON is coming in off the body and then serialize it into something that I can work with. Sorry, not there. Sorry, not the from body, but where I've got JSON stats, sorry, game stats, it's JSON element in there. And, it's quite handy if you don't know the shape of the JSON that you're going to get. So I'm just going to run this I'm just going to launch this in isolation just to show you what I'm looking at and how this particular project runs. And let's just bring that guy up. So here's Swagger automatically kind of there. Now this is the subscriber, if you like, what it's the listening routine, and this is actually the post routine. Now what I can do also is execute Dapper subscribe. And what that does is return back an array of subscribers and the type of information that is being subscribed to. And this is what Dapper, when Dapper starts up, remember how I had that runtime and the port number of the application? This is exactly the reason why we have this, so that Dapper goes away, calls into our application, gets back this information and keeps it internally, so that when it does receive events, it can go, hey, I just got a game, something to the game's topic, and it's a game updated. And, that's exactly what we want to pass to something called game topic for processing via a post. Now, that's kind of how that works at that level. Now, quite handy, and that's, obviously whoever wants to be publishers can be publishers, and that can be done around the globe, and this guy reacts. And we're not talking about Azure Event Grid here. We're not talking about the system event notification service in AWS or Google Cloud equivalent and so on. We're just saying, well, here's how we do it, and here's how a Dapper facade in front of whatever your back-end configuration looks like does it as well. So from our code perspective, we start to get a bit more normalized code, irrespective of what cloud we run on. So something to keep in mind, on this particular example. Now, I did want to just talk to you about this Actor framework a little bit. And there's many different examples and many different ways to go. But what I wanted to kind of talk to you about is that there's a framework here that looks after not only state management within classes, but also the execution of these units of work, if you want to call them that, and the concurrency of these units of work. So think that you've got your own kind of object cluster that you can run thousands of these objects and instances of these objects. And you don't necessarily need to worry about durability, about fault tolerance, because all of that gets handled by the Dapper runtime under the covers. So I want to just show you how we sort of set this stuff up. And then I'll spend maybe 5-10 minutes on it. It's sort of a good overview and a good place to start. We go off and grab this Dapper Actor's NuGet package. Now, the thing that we typically define here is our iActor interface. So we go and inherit off it. And I've just said, go and create a couple of methods. And I've also declared something called game data. So in other words, we've got a game name, we've got a player number, we've got a high score, and there could be, extensive amounts of info. This could be some of your POCO objects. This could be, I'm just keeping it simple. And here I've got two routines. One is, set the data. The other is get the data. And let's just see what that looks like, going forward. And that's typically all that we do. So because we're talking interfaces, so we're talking interfaces between the service that implements them and the client that also wants to call and talk to them. So clients could be other web APIs. They could be, mobile apps. They could be, whatever is capable of handling this sort of stuff. So it doesn't necessarily need to be, as uniform as what you think it might be. So in terms of the service and how it gets implemented, we've got a startup once again, and let's go to this. So here's my Hello World Actor class, this guy here. So remember this. Now, what I did was create a reference to the interfaces. So I said, well, we need to know what those interfaces were. And this particular class inherits off an actor, which is part of the Dapper Actor's runtime. And that makes it behave in a certain way and gives it certain properties and allows it to respond to certain events. So the first thing that this class does is on the constructor, we've got an actor host. So we can find out a lot of details about how I'm running, where I'm running, how much memory I've got, and possibly I can go off and talk to other sub actors as well if I need to, generally through this guy. It makes it quite easy. Now there's a few routines, and I just picked one here and overrode it and just said, well, we're going to activate. So in other words, the Dapper runtime has taken us from being serialized and written out to disk or written out to storage somewhere, and we're just about to run again, or we've been instantiated and we're now going to run. And we've got an ID that sort of we know about. And that's really important, these IDs, because that is how you can uniquely identify that particular actor in the runtime. So if you think of them as GUIDs, then maybe, if you do want to come back to your shopping trolley, you need to preserve that GUID somewhere and say, hey, my shopping trolley is represented by this particular ID, and that's my shopping trolley, or that's my order. I'm in the middle of buying movie tickets, and that's where I'm up to, and I'm going to come back to where I last left off. Now, this is the actual implementation, right? So I've got these two routines, as we previously saw in the interface. Now, this routine could do a whole bunch of things. What I've done is really just made it do one thing. And you'll notice that it's got this dot, and we got a whole raft of things, right? So this dot logger and host and what's my ID and state manager. And, I've also got reminders, and I've also got things like proxy, so I can go off and talk to other things. So the Dapper runtime, so I can actually create an actor here that is a timer. So I can have a timer that kicks off at a certain time. So I could have quite an elaborate and complex scheduling here, or I could just have an actor that runs every minute that takes all the messages off the queue and processes them, right? So there's a lot I can do in this space, but I'm just keeping it very simple. And here we've got this state manager. Just go and save that state for me. Concurrency, how many people, how I'm running it, where I'm running it, is all handled for us. And then if I want to go back to where my saved data was, that's where it is there. There's no, database connection strings. There's no initialization on all this stuff. It's all handled under the covers and behind the scenes for us. So that's sort of the service, and we can extend this out. So these things could do a lot, right? Given this is, acting around some game data, it could go off and play a game. It could go off and call several other back-end stores or, APIs or something like that. But really, this is just a line of code I want to show you. Get me my state data and go and do some code, go and run with it. Now, as far as the client is concerned, the client here is pretty simple. And I just want to show you what that looks like in terms of the NuGet package. So once again, got the actors installed. And let me just go back to that service. So it's one thing to actually have this class, right? It's one thing to say, hey, I've created this class, but how do we let Dapper know that this class actually exists, that this service that we have actually hosts these actors, and they can live within this service, or this service knows how to deal with them. So in the startup, on this service, it's a web project, I've amended the services here and said, well, add these following actors. And so we're registering the Hello World actor class. And then down below, I then got, similar to what we did before, was map the actors handlers. So in other words, go there and call into that actor class if you need to. Now, Dapper looks after the invocation itself, and we don't necessarily need to go through the traditional /API/controller/whatever to get to it. That's all handled for us as part of Dapper. I've just kind of got some overhang and some leftovers from this particular project type that I quickly used to spin up to show you this bit of code. Now, if we go to the client, right? So the client says, I'm going to be talking to these particular types. They can be any sort of, any actors. And the client also has a reference to the interfaces project. So it knows how to talk to these particular types. And what it will do is to create a new ID based on, some value. So this actor ID, this line here is really important, because if I want to go back and talk to a known executing actor, then I need to supply that ID in here. Here I've just gone and arbitrarily chosen one, right? So if you run this, it'll just talk to the actor called one. And depending on the life cycle and the lifetime of that actor, it'll determine how long the Dapper runtime keeps it around for. And then, so the next thing that we do is create a proxy to that actor. Now, the thing that I really like about this is that this actor proxy is something from the Dapper's actor client environment. Now, the iGame actor is from the interfaces. So in other words, we're using a strongly typed proxy to talk to our actor. Now, the client doesn't know where the actor is. It just says, hey, I want to go and talk to you. And I need you to go and process my order. Now, you think about the level of scale, the runtime, maybe there's 1 million orders being done at this point in time. As far as the client is concerned, it's exactly the same. So here I'm building for the one while designing for the millions. And then, so on that proxy, we're actually calling methods that we've set on the actual actor itself via the proxy. Blows you away, huh? And then, so in this case, I'm saying go and set some data, but this could really be anything. But that's just what I've just got on that service. It could be, hey, go and run my game and process it, or make my next move in chess and pass in the chessboard. And that service could work through it and then save the data away, right? And without the client being none the wiser. And then here I just basically say, save it, get a response, and then, talk to the same proxy and, get that, what's your saved, game board or something look like. This is really just a very high level and a very sort of, quick overview of this stuff. But, I can't speak highly enough of it, the fact that there's this logical level of separation between code and services and implementation. And if you start to sort of have a look at even the way that the service is implemented, just focusing on the code at hand, I'm not really worried too much about controllers, about the web, about pages, about the fact that this thing's sort of, like a werewolf, part razor, part, and all this kind of stuff. I really should remove all that from this project. It's really, something that can spin up, listen on the end of a port, and and be answerable to, you know, calls that come into these actor classes. So it's quite a fascinating piece of technology, the you know, the Dapper initiative, and I really quite like it. You can start to see how the lesser amounts of code, if you like, that we can write. So with that, I do want to just wrap up now, but we'll come back to the slides, and I just wanted to sort of reinforce what we've sort of looked at. It's about building smarter, and I think this is one of those technologies that doesn't cost you much to add to your project, but it gives you a lot of capability, particularly if you're thinking about portability, you're thinking about self-containment, you're thinking about isolation, you're thinking about loosely coupled, event-driven, and minimizing the amount of interdependencies between your code. And offload your work. So where do you want to host it? You can host it in a variety of different places, and obviously off the back of a container, go run the container wherever you like. Everything's containerized these days. So I hope you enjoyed it. There was a lot to go through, but we've really just scratched the surface on a lot of this stuff. I only just covered maybe 2 or 3 of those different components of Dapper, where we could actually cover a lot more and have a look at it. But Dapper.io, and start to jump in and get into it. All right, over to you, Bill.
Thanks very much, Mick. That was really good. I hadn't seen any much at all about Dapper, so that was a really good thing. Let me just drop yours there, and I'll add the questions back up. And again, if there's anybody out on the
interwebs,
YouTube live, and wants to ask questions, I'm also going to post up. We've got we've also created a Discord site out there, so that
awesome.
If anybody wants to ask some questions and things like that, that I've posted the link to there in the chat. If anybody wants to, I will also add Renee and Dan back here if they've got any questions or comments. Or actually, let me just bring, yep. So thank you again very much, Mick. And let's see, go on to that. Thanks everyone for tuning in on this. And again, the live recording's out there, but I will also do a cleaned up, edited version of the recording and put it up there in the normal place, and it'll be available through the Integration Down Under website. So beautiful. Thanks everybody for, sorry, I didn't add Dan back in. There he is. So again, thank you very much. And to me, it's just amazing all the different technologies people are building things for and things like that. So right now it's kind of, you really have to do your research to find what you want to use, and then what you get used to using and things like that. So again, thanks everyone. And I think that's pretty much going to be the end of the live stream. And I will talk to everyone later on. Thank you very much.
Thanks, Drew.